last week we reached this page and talking about the cell capacity calculation. Well, later we will have the group discussion. So that we have the group discussion. Right now, I try to review part of chapter 4, and of course, I will go through part of chapter 5 as well. And actually, I have the link, but because of the connection to Paul Abigail, if I have the crossing of different chapter, then some problem happen. So right now, I close the current slides and start the chapter 4. Actually, for chapter 4, I will go through quickly. Doesn't mean I will let you know all the details, because I try to emphasize some content. Later, you need to answer some problem in the group discussion. Okay, wait a moment. All right, so let me go through part of chapter 4 so that you have the knowledge about the question. And later you can use the knowledge to answer the questions. All right. Actually, in chapter 4, we discussed some codes. And later, I try to emphasize the linear block codes. And also that we have some other concept, including interleaving. Therefore, right now, I try to jump to the proper places. All right, linear block codes. Here we have the review. I think almost all you ever heard from the lecture. Right now, I try to emphasize we need to have the special operation, module to addition. Remember, module to addition, if we have a 0, 0 and 1, 1, finally the addition allow you to have 0. So the others actually we will have 1. Well, this is the first operation you need to notice. Well, of course, we will have the similar question as well. And actually, we have an example previously. This example previously that you have the given information, and so that you need to calculate what? Actually, we need to calculate these parity check vector, and so that you have the parity check matrix. Remember that, right? Well, if you want to have the calculation, here we have the corresponding coefficients. All right, but about the discussion here, remember you need to perform the module to addition when you try to find the remainder. Therefore, I try to emphasize the operation of module to addition. All right, once you have the parity check vector, so that you can have the parity check matrix. All right, so you are asked to find the parity check matrix P. And using the current way to form the generator G. Well, first of all, I emphasize this. You have P and then you can have G, generator. And this is a way you can put I and P together to form G. This is first one. Well, about the information, actually we directly have the generator polynomial G of x. All right, and also you need to notice value of k, value of r. And all the information here allow you to have the possible calculation. So this is the way once we have a G, then we can generate the information n by using the way. So n multiply G, then you have the vector, co-vector here. It is a co-vector. Well, I think you can have the relationship as well. Because of a quick review, so I go through all of these quickly. Well, we can have the vector m to denote the message you have. And once you have m, you can multiply g to allow you to generate the co-vector c. Alright, so basically I think you've seen the way to have the messaging and the co-vector by checking the previous pages. I think this is a way to repeat how to have the calculation c equal to m multiply g. And of course, how to form g here. And basically, we got to have the calculation, but how to have the calculation? Remember, we have this one, r, and multiply I minus 1, and I starting from 1 to k. Alright, so just a reminder. Previously, we have those calculations. Actually, those calculations follow the way to get the vector, parity check vector. Once you have all the vector, you can form the parity check matrix. Well, and actually, we draw your attention to have another calculation called this matrix. Alright, the matrix used to find syndrome or not. We have this H. And H, if you want to have the direct calculation, this is a way. You need to transpose the current matrix P and combine the identity matrix I of A minus K and actually I R, and so that you can have the parity check matrix. Alright, so something like these calculation, and so that you can have the possible matrix. And again, this one try to illustrate doesn't mean we may have the new information. Right? So let me go through quickly. Well, if we have all of those, then we can have the way to generate a matrix G. Remember how to form G. And also we have the parity matrix, parity check matrix H transpose HT. Alright, previously we have H to have H directly. Alright, so all of these and they allow us to have calculation. If we have an arrow and then initially no arrow, then we should have a 0. And 0 means no arrow here. However, if we have arrow, then we will find it. Well, because of review, so of course we've seen we have the keyword to that local system to check syndrome. Alright, so this is the reminder of the keyword. Well, this is the previous example to let it have a G and H. Right, so if we don't have arrow, then we will have a O0. The vector, that is no problem at all. If we have an arrow here, then we can find non-zero, and so that we can have a non-zero vector here. Well, this one serves as a syndrome. We can find it, and then no problem. Okay, in the past, we used Paul Abiquial to have your feedback talking about any questions. I think you've seen here, actually almost no, right? So this is the past recording data for Paul Abiquial. This is a past result, and later we will have the new result to input, and so that you can see the dynamic feedback from you. Of course, we have the review, but right now I reserve it because later I will review again to let you know the past activity about the past group discussion. And of course here, these are the selective problems for the good discussion. The set here, of course, they are all problem set for the good discussion. Well, in the past, actually we have the good discussion by asking you to visit Paul Abiquial to key in, right? In fact, I can let you have the activity if I check Paul Abiquial. Right now, maybe no time for me to check the detailed content. So this time, I let you know these Actually, once we reach it, you will know we have the progress for all the groups. Okay, so this one I think I skip it. Of course, we will have the solution. Alright, that's it. This is a review for the linear block codes. And next one, this is an interleaving. Alright, and about interleaving, I think I just go through quickly and let it review how to have the interleaving. Well, about this, I think no more discussion, just let it review how interleaving works. Alright, so later we may have some questions related to interleaving for sure, so that's why I review these. Okay, so this is a part I go through for you because later I may have some questions related to the corresponding part of the review. And right now, let's get back to the discussion for chapter 5 quickly. Okay, so this is a new topic. So we discussed the cellular concept for sure. And we have the outline here. Actually, we have some discussion about the signal strength, head of region. And finally, we have the start of capacity of a cell. Well, I try to review because I reviewed chapter 4 and also I reviewed part of the content in chapter 5. And after that one, later you are letting have the feedback up to now, any question about the review. Well, this is a discussion for cell shape. I think we have the possible choices. We use circular, we use circle, or we use hexagon, or square, or triangle. And of course, normally we will have the irregular shape of the cell. And if you want to have some calculation, we also discuss how to have these formulas. And of course, right now, maybe we don't have the direct application, but later perhaps we need to have the application to the calculation. Well, once we have the cell shape, why? Actually, we want to have the signal strength. Why we want to have a signal strength? Because we can have the boundary. The boundary that we have the equal power level. With the equal power level of signal strength, then we can determine how to have the handle, and so that we can have the handle region. Well, we don't have the perfect cell in circle. Then we can have these. And here, if we have these, then we have the description: contours, tiling, and terrain. And actually, for all of the terms here, maybe I use the term here to let you know. Actually, we can assist you to have the meaning of a contour if you don't know that one. Maybe wait a moment. Actually, I try to let you know and avoid to speak Chinese. That's it. So avoid speaking Chinese. Of course, I prepare the keyword and assist you. Well, this time maybe I review. So this one, let me skip. Actually, we may have the Chinese character to explain contour and for the others. Because of limited time, oh well, you can see. That's it. So we have the explanation on the keyword, but for the point, actually, you try to find the Chinese characters, right? Well, the current Chinese character asks you to have these. A line on a map that joins points of equal height or depth. Okay, so I think we have the English explanation, and also we have the Chinese character directly. So I think once you've seen these, then you can understand the meaning of the keyword, right? Okay, just a review. So I try to highlight these, and also the other two because it takes time. So let me skip the remaining two hyperlinks. Well, of course, this is a hyperlink from Cambridge Dictionary. Well, once we have that, because of the boundary, so that we can have the meaning of panel. And so that we have the strengths. And the strengths allow you to determine the region. And as for the details, I think I skip it because we try to have the review for the next. You see, finally, we will have x sub th to x sub th, and you can have a reverse direction so that in between the 2 points, then it serves as a region, and you can have the handle region. Right? Alright, so handle region here to be highlighted by the dark color. And of course, we then have a problem, and the problem tries to have the optimization. Well, I don't know, just a problem. It doesn't mean for the real situation we will have a formulation like this, but it serves as an exercise. Well, because of exercise, I go too quickly to let you know this is a way to have the calculation. Therefore, we can have the handle rate. And if we want to optimize the parameter, then we can minimize the handle rate. Right? Well, finally, through minimization, so we can have the results here. Okay, I skip. Well, finally, we can have the calculation for the cell capacity. Well, that's all up to now. I think I review some content for you because we will have the good discussion. Well, after that, right now, I think I seek your possible feedback to let me know. Any questions? All right, go ahead. Maybe you can have 1 to 2 minutes to send your feedback through the poll everywhere. Check it. Well, question, no, no, no. Oh, good. And any other possible feedback? Up to now, of course, no. Or maybe some other different feedback? No? Okay. That's good. And any different feedback? Currently, no. Yes. And anything else? No, so far so good? Well, okay, so seems to be no question. That's good, because later we will have the start of a good discussion. All right, finished. I think all of you need to let me have the feedback, or otherwise you fail to get the point, because we have the point for participation. So right now, anyone fail to finish? If yes, raise your hand. Finish for this, the feedback. All right, because I want to switch. Once I switch, and then I think you will fail to key and solve about the point. You will fail to get the point. And let me ask you the question. No one finished? Okay, good. So of course I will try to check the whole everywhere website to get the record for you, and so that you can get 1 point for your point of participation. All right, that's good. You finished. Then we go to the next one. Here, this is a problem. Selective problem from exercise number 2. We have problem 4.4, 4.10, 4.24. And actually for the first one, we let you have the information and actually ask you to check the co-generator matrix G. And the second one asks you to check the parity chart matrix H. Well, remember about the review, I didn't know how to have the calculation of G and how to have the calculation of H. And also I didn't know how it works for interleaving. But the current problem asks you, can you interleave an interleaved signal? All right, so why? And you should have your own reason. And this is a list of the problem set of our group discussion. And actually, before we start the class, actually I already have the problems. I already have the hard copy. So later, if I switch, you can check your hard copy as well. And actually, you can log in Paul Abigail, and Paul Abigail will already have the description of the problems for sure. Well, before we have this, okay, later we will review, but the review actually, you just try to feel for you, can you improve the group discussion by yourself or maybe something else? Later I will play the video, but you can start the group discussion, all right? And right now, this is Paul Abigail to have the good discussion, and later I will get back to play the video, and so that we can review the past good discussion. Well, some of you can key, so right now we can see your status, right? Okay, keep going, and in fact, well,
it should just need to submit one response, right?
Yes, as usual, just a good leader, and this the good leader. Keying the answer to Paul Abigail. And you can pass on the answer on Paul Abigail to have your own group discussion once you key. Maybe you can pass on something you write on the empty page. All right. And later I may ask tutor to have the recording for the discussion. Okay, so this is a page, Paul Abigail, and later I will switch back. But right now I will play the video, but meanwhile, you can have the group discussion. So right now, allow you to have 5 to 10 minutes to have the discussion. Before you guys have the group discussion, I ask you group 1 and group 4. Later, you will have the discussion for problem 1. Group 2 and group 5, later you will have the discussion for number 2. And group 3 and group 6, later you will discuss your answer with us on problem 3. Is that okay? Well, before that one, anyone have any question? No? Then you can start the group discussion right now. 5 to 10 minutes. Okay, go ahead. And right now, let me review this one for you, and you can check for sure. Or maybe you can ignore. So, any question? Right now, maybe not okay for Paul Abigail, that's correct. Right now, I just have the discussion direct, and later I will switch back, and then you can key the answer. No problem.
We can change the line. We can type the message.
No problem. Just have some comment. It doesn't mean I ask you to have all the details on Paul Abigail. No worries. But later, if you can share something you write on the page, just show those content on Skype. Okay, so. Yes, correct. So right now, some groups ask me to finish all the answers for all the problems. At least try to finish the answer to the problem. Later you will discuss and share your idea with us. That's it. So screen you share. The screen you share. Switch. Oh, no problem. Oh, you. So actually, this is the recording video. This is a review. No problem. I thought maybe someone start the discussion. Yeah, this is a task. Task good discussion. Review by group 4. Right now, you have your good discussion. Right now, if you want to check everyone, it's just a review only. At least you need to share your idea later. Doesn't mean I ask you to have the exact calculation. And later possibly we'll try to use Skype to share your possible content. Possibly you can use that. So after you can have a picture share
check that if we have the correct. So we can
possibly you can do it it's just show me the page. I didn't ask you by at least to show H. How do you H? Any question from you? No? Okay, good. So, any question from you? Oh, sure. No problem. And everything's okay for your group? Okay. I think it's almost 5 minutes. And of course, some of you can still have the discussion, no problem. But right now, I try to switch back. And here, to switch back. Of course, this is a review. And this is a past a good discussion. Serving as the way to improve your answering. And so that you know how to improve. And right now, let me get back to this. Alright, so right now I think we have 6 groups. So right now it seems to be all 6 groups finish your answer to Paul everywhere. Am I right? If not yet, you try to have your answer to Power everywhere. And actually, I can see the content. Of course, by checking the page here, you only see the path of working on the problem. If indeed you want to see the content later, I can log in Power everywhere so that I can play the content for you. But right now, I try to seek the possible sharing from all of you. Well, we have one phone to discuss the first problem. So right now, let me tune the volume by my system. So I try to tune my volume. All right, so right now, any group ready to have further discussion? How about group 4? Ready? Can you share the content to Skype? Group 1 ready? Can you share the content to the Skype? Oh, sure. I start from group 1. And try to share your content and so that we can see the content from group 1.
So I just share my content on my screen.
And also turn on the microphone and the camera. And share your screen. Or maybe you can have the handwriting. Try to show your handwriting.
I just share my notes.
Okay, that's good. Go ahead, no problem.
First, we can get the generator matrix by appending the two matrices, which is identity matrix and the parity matrix. And also, we can get some information from the problem. The 7-4 code means the length of the code is 7, and the information base, the length is 4, and the redundant bits is 3, so this should be R.
Okay, I see.
And so the identity matrix IK should be I4.
All right, here, right?
Yes.
Okay, good.
So we get the half part of the generator matrix. And the rest is the parity matrix. We need to get the P1, P4, P3, and P4. So we can get this vector by this equation. So P1 is 101, P2 is 111, P3 is 110, P4 is 011. By appending this vector, we can get the parity matrix. So the answer is here.
All right. Okay, so I think you just follow the previous discussion in the review, and so that you can finish the calculation for matrix G. Okay, good. Thank you. And about this, I think later I can share the reference solution to you as well. But before that, and I think maybe any other different discussion. Oh, go ahead.
Can we change the format to full screen? The words.
Oh, okay. Later, maybe we can allow you to.
No,
right now, maybe right now.
No, we can change it at the,
Oh, okay. Sorry.
like the view option. Yeah. The right, upper right. 检视。
Sorry.
隐藏上方的人员。下面会更大，也是可以直接 full screen 的。OK。
Oh. Okay. Here. Try to adjust this for us. Okay, so later the tutor can assist us to have the proper resizing. And before that one, I think I asked group already. Can you share your screen? Wow, we can see you. That's correct. Oh, so handwriting, right?
So we have the code generator is one plus this one, and from we will get the parity matrix from this equation. This equation, and we're gonna get the remainder, and this is how we get it. And for the P1 we're gonna get 1, 0, 1, and for the P2 we're gonna get 1, 1, 1. For the P3 we're gonna get 1, 1, 0, and for P4 we're gonna get 0, 1, 1. And for the matrix G we're gonna use the identity matrix and the parity matrix, and the parity matrix we're gonna put it on the right side, like this.
Okay, so one moment I ask group 1, check the answer here. Try to start there. Let us look at G. Same as yours?
Yes.
Oh, good. So I think both of them have the correct answer. You just follow the previous procedure to have the calculation, and so that we can have the final answer G. All right, that's it. This is the discussion for problem 1. About problem 1, any questions? If no, right now, let me switch to the third problem, not the second problem. So wait a moment. The third problem, talking about interleaving, and ready for group 3. So,
hello.
Can you repeat the question, and so that later we can understand why you talk to us?
So the question is, can we there's an echo, right?
Yes. So maybe stop sharing. You just let me know the problem and the answer directly. Okay, go ahead.
So the question is, can we interleave an interleave signal, and what will we gain with such a system? After our discussion, we think that we can actually interleave an interleave signal, but there's a